Hello, and welcome to Empowered Learning. This particular video is an example of a linear programming problem that's called an allocation type of example. Basically, what we're trying to do is figure out how many of each type of something will be able to be used for this particular example. I'm going to first describe the background for this particular example, including what we call our objective function along with the constraints, and then from that show how we use the Microsoft Excel solver to be able to figure out the optimum solution for this particular problem. All right, so the background here is we know that we have this trucking company, and the purpose of this trucking company is to basically haul stuff from one location to another. And so the situation that we have here is we have a trucking company, and for this particular contract, they need to be able to deliver fruit from one place to another. So probably from some base manufacturing or hub where they gather this stuff from different farmers or whatnot to take it to a grocery stores. Okay, so we know that we're trying to ship apples, bananas, nectarines, and peaches. Okay, and so we know what we're trying to do is, since this is our trucking company here, we want to maximize the number of boxes of apples, bananas, nectarines, and peaches we can carry per truck, or per trip. The reason for that is, of course, if we can get more boxes packed into our truck, then that's more shipping charges we can charge whoever it is that we're trying to do this for. And of course, the more we charge, the more money we make. Okay, the more money we make, the more profits we get. So we want to try to get as many of these boxes of each type as possible. And so the purpose of this problem is to figure out how many of each could we get in there with our given constraints so that we can maximize our profits, basically. Okay. All right. So here, the shipping charges, these are in dollars. So we see that it's $6.35 per box of apples, $6.45 per box of bananas, $6.36 for each box of nectarines, and $6.50 for each box of peaches. Okay. So our constraints consist of, we know that the total number of boxes we can have is going to be 1,200 boxes. Okay. So for the truck that we're using to deliver all of this, the most that we can put in that particular one box is 1,200. Okay. So these ones here basically mean that we're going to say the number of boxes that we're going to use that are apples times the number of boxes of apples. So all these ones here just mean 1 times the number of apples, 1 times the number of boxes of bananas, 1 times the number of boxes of nectarines, 1 times the number of boxes of peaches. Okay, and so basically A plus B plus N plus P is going to be less than or equal to 1,200. Okay. For the total weight on the boxes, one of the things that we know about the boxes is that each box of apples is going to be 25 pounds. Each box of bananas is going to be 35 pounds. Each box of nectarines is going to be 45 pounds. Each box of peaches is going to be 30 pounds. And we know that for, I guess, fuel efficiency purposes, we have to limit the weight of all that we carry to be 40,000 pounds or less. Okay. And so next is our constraints on the number of available apple, banana, nectarine, and peach boxes. So we know that wherever we're at and we're picking up these boxes of apples, bananas, nectarines, and or peaches, we know that for this time we have a maximum of 600 apple boxes we have, 500 of banana boxes, 450 nectarine boxes, and 350 peach boxes. Okay, and the ones right here represent, of course, 1 times the number of boxes of apples, that would be less than or equal to 600. The blanks everywhere else just says that we assume these to be zeros. In other words, we're not considering bananas, nectarines, or peaches in that case. And so our constraints of the number of boxes has to be less than or equal to 600. Number of banana boxes has to be less than or equal to 500. Number of nectarine boxes has to be 450 or less. Or number of peach boxes has to be 350 or less. This is how we actually write that. Okay. All right. So with all our constraints here, these blue columns, or these blue cells, I should say, are here just to make sure that we stay within our actual constraints here. So if you see up here, we're doing basically sum product. We're just doing this times this, plus that times that, plus that times that, plus that times that. And the total goes here. So that's what that sum product means. Okay? Oops. All right. So for each of these, it's the same thing. So let's say if I go here, okay, we see that it's just going to be 1 times this, plus 0 times that, plus 0 times that, plus 0 times that equals some number that's going to be less than or equal to 600. Okay, and so in the solver is where we're actually going to make sure that these constraints are adhered to. Okay, so we have our shipping charges. We want to maximize these charges. So here we want to take the $6.35 times the number of boxes of apples, $6.45 times the number of banana boxes, $6.36 times the number of nectarine boxes, and $6.50 times the number of peach boxes, and add all of them up. Okay, and you can see that sum product function is indeed trying to do that. All right, so now that we have all that, what we need to do now is use our Microsoft Excel solver to be able to run the numbers here. And so here I went to data, and under data, I go to solver. Okay, if you do not have the solver showing up here, then you're going to need to read instructions for how to go about actually making that active on your particular version of Microsoft Excel. Okay, so if we run the solver, go ahead and click on it, you'll see here that we have the objective cell, which is F6. And so this is what we're trying to maximize. So that's why we have this here selected at maximum. And we're going to maximize this cell by changing all the cells that are in yellow. So that's B5 through E5. Okay, and so how we actually select this, of course, I'm going to erase and do it again. We'll come here and click right there, select that, and then put it back. And of course, you see the fruit transportation thing because the tab that I'm working in on this particular workbook is the fruit transportation. Okay, so same thing with cells B5 to E5. We come here, click here, select all these cells, and then click. And so we see that it captures those. For the constraints, you'll see that all these are less than. So what I'm actually going to do is add a constraint that's going to include all of these all at once, since all of these are less than, and get rid of these other two. So I'm going to go to add. And so I want to make sure that all these constraints are met. So I'll go click here and go from F8 to F13. And then I want less than or equal to, like how I have it here. So of course you see that's the list. I just select that one. And then for the right hand side constraint, I come click and I highlight all that, put it there. Okay. And then you see I have that constraint. So everything from should be from F8 on to F13, and H13. So it's this one that's in the middle here. So I want to take this one and delete, take that one and delete. And so if you're doing this originally, either you already see this stuff in here or you'll have to make it up on your own. So that's why I'm kind of going through it to show you in either case how you would end up having to do it. Okay, so now once we're here, we want to make sure that you have this checked to make sure that all of our variables, A, B, N, and P are non-negative, meaning that the answers that we get are greater than or equal to 0. And of course, for the solving method, we want to do simplex LP or simplex linear programming. For the options, you pretty much want to leave all this the way that it is, especially if you're just starting out using this. But we want to make sure that we have use automatic scaling here. Okay, press OK, and then from that point, we just solve, and we'll wait a little while, and we see that we get these numbers here. Okay, so it says keep your solutions or restore the original values. We want to keep a solution, so we'll just hit OK. Again, here in the reports, we have answer sensitivity and limits analysis. And so if you're needing to do a deeper dive into seeing for your optimal solution that you have here, what is your flexibility on that, then we would look into some of these reports here. But that's out of the scope of this video. Okay, so we just click OK, and now we see we have 188 boxes of apples, 500 boxes of bananas, 163 bottles of nectarines, and 350 boxes of peaches is what we will need to have in order to maximize our shipping charges, which is $7,723.31. So if this is our company, this is what we plan on making to deliver these boxes of fruit to their respective destination or destinations. Okay? And so this concludes the video on the linear programming allocation example.